Chapter 4. Collections and Arrays. Understanding collections and arrays in Python equips students with essential skills for managing and organizing data efficiently. These concepts are fundamental to many programming tasks, enabling students to work with diverse data sets, optimize code performance, and leverage Python's versatile functionalities. Proficiency in collections and arrays facilitates students' growth as competent Python programmers and lays a strong foundation for more complex data manipulation and analysis in the future. In Python, the built-in collections module provides specialized data structures that are more powerful and efficient than the built-in data structures like lists, tuples, and dictionaries. One of the commonly used data structures from the collections module is DEC, which stand for double-ended queues. Additionally, arrays in Python can be created using the array module from the Python standard library. Let's explore the collections, DEC, and arrays in Python with examples and explanations. First, using collections DEC. The collection DEC is a data structure that allows fast appends and pops from both ends, making it a useful container for implementing queues and stacks. Examples: output. Explanation. In this example, we create a DEC called myDEC with elements 1, 2, 3, 4, 5. Using the append method, we add elements 6 and 7 to the right end of the DEC, and with append left, we add elements 0 and -1 to the left end. The DEC now contains 0, 1, 2, 3, 4, 5, 6, 7. Next, we remove elements from the right end using pop, removing 7, and then from the left end using pop left, removing 0. The DEC now contains 1, 2, 3, 4, 5. Second, using arrays. In Python, arrays can be created using the array module from the Python standard library. Example: output. Explanation. In this example, we create an array called myArray with integer elements 1, 2, 3, 4, 5 using the array constructor. We can access elements using index, and we can modify an element at a specific index using assignment. The append method adds an element to the end to the array. In this case, adding 7 to the array. However, the array module does not provide a direct method to remove an element. To remove an element, we convert the array to a list using the toList method. Then, we use the lists remover method to remove the desired element and convert the list back to an array. Both collections DEC and arrays provide different advantages based on specific use cases. Collections DEC is preferable for fast appends and pops from both ends, whereas arrays offer efficient storage for homogeneous data and are useful when working with large data sets. Overall, these data structures help to optimize specific operations and are valuable tools for Python developers. Let us now understand the functioning of arrays with the help of examples. Example 1. Program to find a perfect square. A perfect square is a number that is a square of an integer. In other words, it is the result of multiplying an integer by itself. To find whether a given number is a perfect square or not, we can calculate the square root of the number and check if it is an integer. Here is a Python program to find a perfect square. Output. Explanation. In this program, we define a function called isPerfectSquare num that takes a number num as input. We calculate the square root of the number using the exponentation operator with the exponent 0.5. We then check if the square root is an integer by comparing it with its integer value using int square root equal to square root. If the square root is an integer, it means that the original number is a perfect square and the function returns true. Otherwise, it returns false. In the example usage, we call the function with number is equal to 25 and the program correctly identifies that 25 is a perfect square and prints the corresponding message. Example 2. Create a list of animals and print out the contents. Output. Explanation. In this example, we create a list called animals containing 5 animals named dog, cat, elephant, lion and tiger. We then use a for loop to iterate through each element in the animals list and print each animal name using the print function. The loop will go through the list one by one, printing the name of each animal on a new line. As a result, the program outputs the list of animals, one name per line as shown in the output section. Example 3. Find the sum of elements in an array. To find the sum of elements in an array, you can use a loop to iterate through each element and accumulate their values. Alternatively, you can use built-in functions like sum in Python, which simplifies the process. Here's how to find the sum of elements in an array using both approaches. First, using a loop. Output. Explanation. In this example, we define a function arraysum r that takes an array r as input. We initialize a variable total sum to 0 and then we use a for loop to iterate through each element num in the array. We add each element num to the total sum in each iteration. After iterating through all elements, the function returns the final value of total sum, which represents the sum of all elements in the array. Second, using sum function. Output. Explanation. In this example, we have a list called myArray containing elements 1, 2, 3, 4, 5. We use the bulletin sum function to calculate the sum of all elements in the list. The sum function takes an iterable such as a list as input and returns the sum of all elements. In this case, sum myArray calculates the sum of 1, 2, 3, 4, 5, which is 15. Both methods yield the same result of 15, which represents the sum of elements in the given array. The sum function provides a concise way to find the sum without requiring an explicit loop, making the code cleaner and easier to read. Example 4. Print the first element and last element of an array. Reverse it and again print the first and last elements. To print the first and last elements of an array, reverse the array and then print the first and last elements again. You can use array slicing in Python. Array slicing allows you to access specific elements or subsets of an array based on their keys. Here is how to do it. Output. Explanation. In this example, we define a function called print first last elements r that takes an array r as input. We first print the first element of the array using r0 as the index 0 represents the first element. Second, next we print the last element of the array using r minus 1. The negative index minus 1 represents the last element, minus 2 represents the second to last, and so on. Third, we create a reversed version of the array by using slicing r minus 1. The slicing technique with minus 1 reverses the order of the elements in the array. Fourth, finally we print the first and last elements of the reversed array, demonstrating that it has been successfully reversed. In the example usage, we create an array myArray with elements 1, 2, 3, 4, 5. We then call the print first last elements function with myArray, and the program prints the first and last elements of the original array and the reversed array as shown in the output. Example 5. Add an element to the end of an array. To the end of an array in Python, you can use the append method for lists or use the numpy append function for numpy arrays. First, using append for lists. Output. Explanation. In this example, we have a list called mylist containing elements 1, 2, 3, 4, 5. To add an element to the AND of the list, we use the append method and pass the new element, in this case 6, as an argument. The append method modifies the list in place, adding the new element to the AND. After appending 6, the list becomes 1, 2, 3, 4, 5, 6 and we print the updated list.